Hi guys. I want to have a quick look here at question 11 from last week. I know one or two people were looking out to correct this, and I now have my pen working again. So happy days, we're back in business. So question 11. A scooter manufacturer wishes to determine how many of their scooters are defective. According to their research, the two main defects of their scooters are broken bowls and/or loose wheels. Their survey indicates that the probability of a scooter having broken bowls is 0.05. So that's like 5% if we're thinking percentage terms. So let's just highlight that. I like to highlight things that are important when it comes to these things. So broken bowls, the chances of that is 5% or 0.05. A scooter that has broken bowls has a probability of 0.7, so 70% of having a loose wheel. So very high chance of having a loose wheel if there are broken bowls. A scooter that doesn't have broken bowls has a probability of 0.8, 0.08 of having loose wheels. So basically, if the bolts are okay, there's only an 8% chance of having loose wheels. Okay, a scooter is chosen at random from the assembly line. Find the probability that it's broken bolts only. Okay, I think before we get started, let's just write down a couple of things. Let's organize our answer. So let's say B is for let's say the bolt is okay. Let's say B is for a broken bolt. So this is just about organizing your answer. It's not necessary, but it does help. W is for wheel. Okay, wheel okay. And LW, let's say for loose wheel. Okay, now what's going on here? Okay, let's let a tree diagram would be useful here in this case. Okay, so there's two things kind of going on here. You could have a bolt that's fine or a bolt that's broke. Okay, so two things. So a bolt that's fine, or B, so bolt okay, or a broken bolt. Okay, then you could have, what about the wheels? You could have a wheel that's fine or a loose wheel. And that can happen down here too. Now, there's a higher percentage, a probability of a loose wheel if the bolt, so there's this one, if the bolt is broken, then there's a higher chance of a loose wheel. But if the bolt is fine, then there's a higher chance of the wheel being okay. Now we can work out these probabilities, and that is what they're asking. Tree diagram is useful in this case. We can actually, maybe let's fill in on our tree diagram. We've it done already, so we may as well just fill in the probabilities. Put in probabilities in green. Okay, they've given us the probabilities in what you call it, decimal form. So let's do that. So let's do decimal form. So their survey indicates, I'm just going back to the question here, that the probability of a scooter having broken bolts is 0.05. So broken bolts, 0.05. Okay, so that means that's 5%. So the chances of a bolt being okay is 95% or 0.95. Okay. Now, a scooter that has a broken bolt, so the one that has a broken bolt, has a probability of 0.7, so 70% of a loose wheel. So let's say a broken bolt, then you're going to have a 0.7 chance of a loose wheel. So I put that in the wrong place. So that must mean that there's a 0.3 or 30% chance of the wheel being okay. Now, what else have they told us? A scooter that doesn't have a broken bolt has a probability of 0.08 of having loose wheels. So let's say the bolt is okay, then you're going to have a loose wheel, you're going to have 8% chance of a loose wheel, or 92% chance of, no, I think again, I wrote those the wrong way around. That's okay, mistakes happen. So if the bolt is okay, the chance of having a loose wheel is 0.08. And you know what? I wrote that right the first time. So the chance of having a wheel that's okay, if the bolt is okay, there's a really good chance that the wheel is okay. 92% chance. Okay. Now, what are our outcomes here? Okay. Look, again, they haven't asked us to do any of this, but this stuff is useful. You know, it's just handy. So you could have a bolt okay, a wheel okay. And we could work out the probabilities of these by multiplying the 0.95 multiplied by the 0.92. We could work out that probability of that. We won't do that for now. You could have bolt okay and a loose wheel. There's a less chance of it, but it could happen. You could have a broken bolt and wheel okay, or a broken bolt and a loose wheel. Okay, and we can work out all the probabilities of those, and that's what they're going to be asking for us in a second, okay? So, yeah, there's a lot of information there. Now let's look at the question. So what about broken bolts only? So, broken bolts only. That would mean that you'd have the probability of broken bolt but wheel okay. So that's broken bolt but wheel okay. So you're looking at this one. They're talking about the probability of this one for the first one. Well, so yeah, we can do it here. So broken bolt is 0.05 and wheel okay. So remember, and means multiply. Wheel okay, 0.3. Okay, and that works out at 0.015, and that's our answer. Now, they didn't ask us to do it as a percentage, but as a percentage, that'd be 1.5%. Okay, part 2, loose wheels only. So loose wheels only. So that would mean that the bolt is okay, but it has a loose wheel. So we're looking at this one, okay, for part 2. So bolt okay is 0.95 and loose wheel 0.08. Okay, multiply that out, we get 0.076, or if we were to change that to percentage, it'd be 7.6%. Okay, that's part 2. Part 3, one of these defects. So one of these defects. So you're talking about, so for part, I think for part 3, I'll do that. I'll do part 3 down here. So we're talking here now about the probability of having a bolt okay, but a loose wheel, or, remember, or means to add, the probability of having a broken bolt, but the wheel is okay. Well, we've worked out the probabilities for both of these already. So here's the first one, and we found that to be 0.076, or means to add. And the probability of a broken ball and a wheel okay was 0.015. Okay, we add those together and that'll give us our answer. So the probability of just having one of these defects and not the other is 9.1% basically. So that would mean, that tells us that it's unlikely that you'll just have one defect. You'll if you have the broken balls, you'll more than likely have the loose wheel. Okay, or if you have a loose wheel, you'll have a broken bolt. Okay, so that's what that tells us. Now, what about part IV? Both of these defects. So that will mean and. So the probability of having a broken bolt and a loose wheel. A broken bolt, well, I think we can go back up to our tree diagram to do this. So a broken bolt and a loose wheel. This one. Okay, so this will be for part 4. So let's see, did I have I this right? I think I got rid of, there should be another B here, shouldn't there? Yeah. So broken bolt, well, a broken bolt is 0.05 and means multiply a loose wheel. Okay, that works out at 0.035. So the probability of having a broken bolt and a loose wheel is 3.5%. So that'll do for that bit. And the last question, at least one of these defects, at least. Well, hopefully by now if whenever they have these at least questions, it's a good idea to work out what the probability of having none and then just subtracting it. So the probability of having no defect. So what's the probability of having bolt okay, wheel okay, bolt okay, let's do that, this one. Bolt okay, wheel okay. Well, bolt okay, 95% chance of that. Wheel okay is that. And let's multiply them out. So 0.95 multiplied by 0.92. So there's a good chance of this, 0.874. So an 87.4% chance of that. So the probability of nothing being wrong is 0.87 or 87.4%. So to figure out what's the probability of having at least one of these defects, subtract it from 1. 1 minus, because remember in probability, you always, whatever the outcomes are, it has to add to 1. So the chances of having something wrong, at least one of these things wrong, is 12.6% or 0.126. Okay, I'll leave it at that. That's question 11. Any questions, just email me about it, please.